July, experiment at the Large Hadron Collider discovered the Higgs boson. It was a historical day. There's no doubt that from now on, the 4th July will be remembered not as the day the Declaration of Independence, but as the day of the discovery of the Higgs boson. Well, at least here at CERN. But for me, the biggest surprise of the day was that there was no big surprise. In the eye of theoretical physics, the Higgs boson is a clever explanation of how some elementary particles get missed, but it seems a fairly unsatisfactory and incomplete solution. Too many questions are left unanswered. The Higgs boson does not share the beauty, the symmetry, the elegance of the return of the elementary particle world. For this reason, the majority of theoretical physicists believe that the Higgs boson could not be a full story. We were expecting a particle and new phenomenon accompanying the Higgs boson. Instead, so far the measurements coming from the LHC show no seed over particle and unexpected phenomenon. Of course, the verdict is not definitive. In 2015, the LHC will almost double the energy the colliding protons, and thus more powerful collisions will allow us to explore further the particle world, and we will clearly learn much more. But for the moment, since we have found no evidence for new phenomenon, let us suppose that the particle the way we know today, including the biggest Hassan, are the only elementary particles in nature, even at energy much larger than what we have explored so far. Let's see where this hypothesis is going to lead us. We will find a surprising and intriguing result about our universe. And to explain my point, let me first tell you what the Higgs is about. And to do so, we have to go back to 1/10 of a billion of a second after the Big Bang. And according to the Higgs theory, at that instant, a dramatic event took place in the universe. Space-time underwent a phase transition. It was something very similar to the phase transition that occurs when water turns into ice below 0 degrees. But in our case, the phase transition is not a change in the way the molecules are arranged inside the material, but it's about a change of the very fabric of space-time. During this phase transition, empty space becomes filled with a substance that we now call Higgs field. And this substance might seem invisible to us, but it has a physical reality. It surrounds us all the time, just like the air we breathe in this room. And some elementary particles interact with this substance, getting energy in the process. And this intrinsic energy is what we call the mass of particle. And by discovering the Higgs boson, the LHC has conclusively proven that this substance is real. Because it is the stuff the Higgs bosons are made of. And this, in a nutshell, is the essence of the Higgs story. But this story is far more interesting than that. By studying the Higgs theory, theoretical physicists discovered not through an experiment but with the power of mathematics, that the Higgs field does not necessarily exist only in the form that we observe today. Just like matter can exist as liquid or solid, so the Higgs field, the substance that fills our space-time, could exist in two states. Besides the known Higgs state, There could be a second state in which the Higgs field is a billion times denser than what we observe today, and the meristation of another state of the Higgs field poses a potential problem. This is because, according to the laws of quantum mechanics, it is possible to have transition between two states, even in the presence of an energy barrier separating the two thoughts, and the phenomenon is called, quite appropriately, quantum tunneling. Cause of quantum tunneling, I could disappear from this room and reappear in the next room, practically penetrating the wall, but don't expect me to actually perform the trick in front of your eyes, because the probability for me to penetrate the wall is ridiculously small. You will have to wait a really long time before it happens, but believe me, quantum tunneling is a real phenomenon, and it was being observed in many systems. For instance, the tunnel diode, a component used in electronics, worth thanks to the wonders of quantum tunneling. But let's go back to the Higgs field. If the ultra-dense Higgs state existed, that because of quantum tunneling, a bubble of this state could suddenly appear in a certain place of the universe at a certain time, and it is analogous to what happens when you boil water. Bubbles of vapor from inside the water, then they expand, turning liquid into gas. In the same way, a bubble of the ultra-dense Higgs state could come into existence because of a quantum tunneling. The bubble will then expand at the speed of light, invading all space, and turning the Higgs field from the familiar state into a new state.